So we know what happens when you add outside the function and subtract inside the function, but what happens when you start multiplying or dividing? Look at this. F of x is equal to x squared, and y is equal to f of x. So what happens when we multiply f of x by -1? So f of x is equal to x squared. So here, f of x, if you input x, it would be 1 squared, which is 1. So f of x would be equal to 1. And y is equal to negative f of x. So this actually turns into -1. -1 squared is 1. Turns into -1. Every output of f of x is multiplied by -1. So this graph looks like this. So we could just say that y is equal to negative x squared. And then, just multiply this by -1, and y is equal to negative x squared. We can recognize that f of x here is equal to x squared plus 1, and if we transform this to y equals negative f of x, it would be y equals negative x squared plus 1, which makes this y equals negative x. You distribute it, negative x squared minus 1. So yeah, the mapping notation would go x, y, arrow sign. Our x values aren't being affected. Look, even though the graph is changing, our x values stay the same. 1 here is still 1 here. -1 here is still -1 here. Sorry for the really bad graph. But our y values are being affected. When y is 1, transformed, it's -1. When it's 2, transformed, it's -2. So this is the mapping notation. And the line of reflection would be the y-axis, or x equals 0. That would be the line of reflection. So take a look at this function, and what if we multiply the outside of this function by -1? And remember, the inside of the function is not being tampered with, it's the outside of the function. The y values are being tampered with. So y equals 0, right here. This times -1 is still 0. And then this is also y equals 0. 0 times -1 is still 0, right? And then here, this point is -1. So multiply -1 by -1, you get +1. I'm gonna, let's approximate this point to be like 5.5. And then multiply 5.5 by -1. We go all the way down here, and the graph is gonna look something like this. And as we can see, these points on the graph, which I'm going to circle in red, didn't change after the transformation, so they are invariant. It doesn't vary. And you can also notice that's the x-intercepts, which makes sense. X-intercepts occur when y equals 0. So we know what happens when you multiply the outside of the function by -1. It just multiplies the y values by -1. But what happens if you were to do y is equal to f of -x? Let's test it out. Let's see. Let's use -4 as our point for x. Y equals f of negative, and then the x value -4, and then y is equal to f of 4. What is f of 4? Well, if we look for x equals 4, we can see that f of 4 is -1. So y would be equal to -1. So when x is equal to -4, then y is -1. So let's put that right here. So we could do this process over and over, but what it really means is just that you multiply the x value by -1 to graph it. But all it means is instead of multiplying the y value by -1, you're now multiplying the x value by -1 without changing the y value to graph the transformation. So the y values, they're unaffected. It's just the x values that change. 3 times -1 is -3. And then we look here, x equals 0. Well, what is 0 times -1? Still 0. So that remains the same. And then here, the x value is -2. Times that by -1, you get 2. And then here, -4 times -1 is 4. So this will be your transformed graph. I hope this graph looks nicer than the other ones. So f of x has been transformed, and the transformation is that we have reflected it in the y-axis. So whenever you're affecting the x values, so like, this type of y equals f of -x, then it's going to be reflected in the opposite axis. So in this case, the y-axis. And then if we had y equals -f of x, it would just be reflected in the x-axis because it's opposite of the values being affected in that function, which are the y values. And to put this in mapping notation, our y values are not being affected, just our x values, so we write it as this. And then variant point would be this because it doesn't change. And that makes sense because x equals 0 there. Or you can choose to remember it like this. Just, if your x values are being affected, it's being reflected in the y-axis because the y is different from x. But if you remember mine, it'll make these questions like you instantly know what to do, because it's telling you to stretch the graph about the x-axis. So that means the y values will be affected. If you link it back to my explanation, it's just the opposite of what I am saying. So it wants to stretch the y values by a factor of 2. So let's do just that. 3, 6, 1. So it would look like this. And you would just write y is equal to 2f of x, because the y values are being affected, so you put the factor outside the function, not inside, because then you'd be affecting the x values. So now it's telling you to vertically stretch f of x. Well, it's telling you to stretch it vertically. So clearly we're not affecting the x values, as that'd be stretching it horizontally. We're stretching the y values. So let's just do precisely that. Y equals 1, there. 4 equals 4 divided by 2. It'll look something like that. And because the y values are being affected, you just put it outside the function. And because we know f of x is x squared, we can just say y equals 1 over 2 x squared. This just becomes 1 over 2 x squared without the brackets, just to make it look nicer. So what if we now begin horizontally stretching? So let's try that. And horizontally stretch means we affect the x values. Well, 0 times 2 is 0. 1 times 2 will be 2. 2 times 2 is 4. And now I'm gonna make a really good graph here. Let's do this. Curve it. fix it up a little bit. And yeah, so this is what the graph looks like. And so y is equal to f of x, and f of x is equal to x squared. So y is equal to x squared, and because it's a factor of 2, I bet we're about to say y equals to x squared. Clearly this is not the case here. So this looks kind of wide. So what you need to remember is the verbal description is, yes, we're stretching it by a factor of 2, but in the equation it wouldn't be y equals f of 2x. You would do the opposite of 2, which is the reciprocal, 1 over 2x. That would be your equation. And putting this into mapping notation, right, you have to make sure it matches the verbal description. The mapping notation and the equation are separate. The mapping notation just means what you want to say. 2x, y. Okay, so let's do our thing for the graph first. We're horizontally stretching, so we just affect the x values. -3 times 1 over 2 is -1.5. So we'll put that like right here. And then 2 times 1 over 2 is 1. Okay, x equals 1 becomes 0.5. And then this becomes 1.5 right here. So let's hope I make the best graph ever. So when we write the equation, we're just gonna write the opposite of the verbal description. So the reciprocal of 1 over 2 is 2x. But then in mapping notation, it would be matching the verbal description. So you can pause here, solve this by yourself, but here's where we should begin. To start off, we can see that this graph is obviously -x squared plus 4, and y is equal to f of the horizontal stretch. Let's call it b. Now here's what we're gonna do. We're gonna replace this with the actual function, right? Y equals -x squared plus 4. Now where does b fit into this? Would you say that we should put b beside the x, like so? So like this. If you do say that, that would be wrong, because this would actually vertically stretch the graph. Instead, keep this like that, and once again, because we're only affecting the x values, we group b in with x in the original function. We group b with x because b only affects the x values, and then we just keep everything else in the function the same, but group b and x together. So now we can just simply solve for b. So we're going to use our point here, 3,0, okay? 0 is equal to -b3 squared plus 4. Okay, so now let's move this to the other side. 3b squared is equal to 4. Okay, apply the square. 9b squared is equal to 4. So isolate b. B squared is equal to 4 over 9. And then after you have b squared is equal to 4 over 9, you square root both sides, and you'll have plus or minus b is equal to 2 over 3. And yeah, we don't consider the negative result for b because that would reflect it, and as the question states, no other transformations can be used, just horizontal transformations. So b is equal to 2 over 3. So yeah, the equation is y is equal to -2 over 3x squared plus 4. So you may be wondering, wait, if b is 2 over 3, why are the x values getting bigger instead of smaller? Because remember, we found what b was in the equation, but when we map this out in mapping notation, we're going to take the opposite of the equation. So that'd be 3 over 2 x y. And the invariant point would just be when x is equal to 0.